Hey guys, again, welcome to Bridge 2021. And we're going to kick things off here with a topic called Intro to Limits. And what you're going to see in all of our videos at the beginning is this little image of this bridge here. And I think it's such a great visual, and it's not an accident that we've chosen this word. And it's just simply any bridge is a method of means of getting you from where you currently are to a destination you want to get to. And over the next couple of weeks, we're going to travel this bridge as we get, closer and closer to AP calculus and ultimately not only a pure, deep understanding of, an elite form of mathematics, but that college credit and that resume boosting material that we're going after. So without further ado, we're going to jump into this idea of limits. And first of all, I think before we really talk about limits, we got to ask ourselves, like, what is calculus? And certainly this idea that motion and things that are changing are the very essence of life. They're all around us in ways that we don't even recognize half the time. But these tools that you've studied up to this point, the algebra, the geometry, the trigonometry, they're what we consider static topics, things that, you've got numbers, points, lines, equations, et cetera, et cetera, et cetera, that they're still objects. They don't incorporate motion. And what we're going to have to try to do is kind of bring them to life with calculus. So mathematicians developed calculus not that long ago, really, when you think of the big picture of things. And that provided us a way to take static tools and use them to analyze motion and things that change. We've used algebra, geometry, and trigonometry for nearly 2,000 years. And all of a sudden, we kind of stumbled upon this revolutionary concept called limits that just changed everything and kind of gave birth to this idea of calculus. So when you think of calculus, think of these stories or these ideas in your head. You toss a rock into a pond, and what naturally happens? You see this ever cascading ripple in the pond. Well, what if you said, well, at what rate is the size of those circular ripples increasing? Or maybe your dog grabs the end of the toilet paper and roll and starts running through the room and around the house. Of course, that roll of toilet paper is shrinking, and you could say, well, at what rate is the radius of that toilet paper decreasing? Or if rain falls, and of course the intensity of the rain changes. Sometimes it rains hard, sometimes it rains not so hard. If you had a function f that represented the rate at which the rain was coming down throughout the day, could you use that to calculate the total amount of rainfall throughout the day that your garden got? Those are all things about motion and change that we're going to get into here before too long. So as we kind of alluded to, limits are really what set the stage. And the most important definition that we're going to put in our notebook here today is the idea that a limit measures a function's intended height, okay? Not necessarily its actual height. So when I say intended height, it's more about what is the function trending towards? What do you think it's about to approach? Whether it actually gets there or not, we don't care. Okay. And a more formal way of wording this is we could say as the input, and whenever I say input, think of the X values. As they get closer and closer to a specific value, what do the output values get closer and closer to? So the output values are like your Y values. And when you look at a graph, these are the heights of your function. Okay. So here's a real simple illustration here. So we've got this set point. We'll say the set point at A, and we want to know what is the function's limit as X approaches A. So first of all, we like to approach this from both sides. We call these the one-sided limits. So as X gets closer and closer to A, this is called from the left side. As we approach A from the left, the function's height is getting closer and closer to L. And then, or if I jump to the other side and I approach A from the right, you'll see where, again, the heights are getting closer and closer to L. Now, this open circle we have in the middle is called a hole. Oh, dear. So this open circle here is called a hole, and that says that the function's technically undefined at A, and that's okay. The limit still exists because, again, we're focusing on intended height, right? We're intending to reach a height of L. From both sides, we are intending to reach a height of L.